Hello, I'm Jimmy Shah. I work with McAfee and mobile security solutions, or whatever you want to call it. My thing is mobile devices, tiny devices, anything small in a car. If it has a microprocessor in it, we deal with it, or at least the threats to it. Who we are? Whoa, did I skip a step? Okay, we're mobile antivirus researchers. We deal with threats to device like malware, viruses, Trojans, the whole 9 yards. Work with a team of people in globally located parts of Asia, parts of in America, around. We are never sleeping or something like that. So we specialize in pretty much every platform. If you have something new coming out, we're probably looking at it also. And we work with a bunch of mobile carriers and manufacturers, and pretty much anything in the mobile space, we're tied up with that. Okay, let's go quickly through this first few slides. We're currently seeing about 1,200 different variants of mobile malware. The pie chart's a good way of showing you the layout of overall what we have seen. The big slice is Symbian, which was now nearly gone with many backers pulling out. But for a certain time, it was pretty much the largest affected platform, period, followed closely by mobile Java, and then the new and upcomer of Android, which is similar but not quite mobile Java. And actually, if you look at our quarterly stats, we're actually seeing Android creeping up on mobile Java and the Symbian falling down. And I think the most current new malware we're seeing is all Android. So we'll be seeing more of those at the end. Let's take a quick look at historical for-profit malware. For-profit malware would be, the first one pretty much was Java Red Browser A, which was a fake web browser, and it pretended to be a WAP browser. So okay, over SMS. So it was a Trojan, and it put a lot of effort into fooling you, thinking, yeah, okay, we'll send an SMS out there, and we'll be able to browse the internet, and it'll be cheaper than using a data plan. Nice, didn't do that. I'll just send out a bunch of messages to a bunch of Russian SMS premium rate services. And then it was followed quickly by Wesber, which didn't even try any of the techniques used by Red Browser, and it was just like a mugging, really. And those were the first ones. The first few we ever saw was about 4 or 5 years ago. What we see generally with mobile malware, and pretty much mobile malware on any platform, is sort of a life cycle of how it goes. The first stage is the R&D stage, where we have people like virus zine writers, other hackers perhaps, or what do you call it? Security researchers looking into making proof of concepts and putting them together, and writing tutorials, putting out papers, putting out presentations, teaching people how to deal with the platform, how to figure out what APIs to use, figure out what we're doing with it, or what people are doing with it. That's followed relatively shortly after you get the first big rush of people by the reuse, not the cycle, so I guess whatever you want to call that. Next stage, you'll notice all the bugs are very similar, but they look a little different. They're cosmetically different in that they have different colors. That tends to happen quite a bit with malware. Once people have gotten through the whole, what APIs do we use, what can we pull off on the platform, why don't we just reuse the code and just change the strings or something? That's what usually happens. After those two stages are done, though, it's what this talk is actually about. How do people make money once they decided to go into malware? Like, what do we do next? We've done the creative part, we've done all the repetitive part, and the copycat stuff. How do we actually put money in our wallets? And that's really what the rest of it's going to be. Let's look at modern, more for-profit malware, where you're actually here. Here are trends by geographical region. You'll see the map here. We have rough regions like North America and South America and Africa, Western Europe, Eastern Europe, Asia, Australia. We haven't really seen a lot of mobile malware coming out of America. We're suspecting that might be because we have so many ways to make money legitimately, maybe. Could be. We have the app stores where you can sell your apps there and make a lot of money. Okay, we can make a fart app and sell it for like what? I don't know, $1 now. I mean, they've actually driven the price down from whatever it was, like $25 down to or $10. Or if you bought that app, what was it? I'm Rich Bitch for like $9,999, whatever the top limit is on the App Store, Apple App Store. I think they sold about 2 copies because people thought it was a joke, but they didn't read the EULA. What was that? I'm a human centipede, South Park. Yeah, read the EULA or you get stuck, apparently. So we don't see a lot in America, and not too much in South America. We're not sure why exactly, but and not too much in Africa. Part of this in the other parts of the world outside of North America is that it's not as profitable to have or to purchase a smartphone. It's a really large part of your income, and if you're not likely to have one, you're probably going to have a feature phone that just runs Java and maybe a couple MP3s or video files, something simple. So we pulled them out of the mix, the geographical region, and we end up with basically Western Europe, where we saw maybe one or two things, and that's actually tied to Australia, where we saw the IQ worm. We call it, at McAfee, we call that OSX slash rroll.A through C. So the first two versions, the Y3 variants, the first two versions were by the guy Ashley Towns, IKEY, or IKEX, I forget what his handle is. He wrote this worm for jailbroken iPhones, and it basically replaced the background image with Rick Astley. So it's like, yeah, all right, awesome. So you're going after all this, and he managed to release source code for those two worms, and at the same time, or a little bit after, he got picked up as a legitimate app developer. He got a real job out of writing mobile malware, or a worm. But the key point of that is how that ties into Europe is that the next variant turned into, someone actually tried to turn that into something that actually makes them money directly from the app, or from the worm, which is like, instead of just doing the worm that just replaced it with Rick Astley and does a bunch of nonsense. The next step turned into was a phishing worm. It was the RLC, some people call it IKB. Basically, it was two pieces. One was a downloader script, and one was it was basically the propagation portion of the original Rickrolling worm to like push it onto every jailbroken iPhone and get it out there. And a different part that what tempted, if you've seen all the analysis, it says, oh, it sends SMS, does this, does that, whatever. All it really did was add a new host file to replace a local European banking website with that of a server under control of the attacker. So a CNC server is somewhere in a different location, and you go to your website, you ship to them, and they take your money, which is kind of nice for the attacker, not for anyone else. That was also closed down pretty quickly because it was pretty obvious what they were doing. Banks shut down quickly. So we kind of move on from them. We move on to basically what's left, because we don't see, outside of those jailbroken phones, we don't see much on any other real phones, or regular phones, say an Android phone or Windows Mobile, yeah, or pretty much anything like that, any other option, or WebOS or anything else. What we're really seeing is that there are basically two regions, places that there are Russian-speaking areas and Chinese-speaking areas, pretty much, and it splits into basically, okay, we got about 100 odd variants from the Russian-speaking areas, and about 200 plus, all nearly doubled, pretty much, coming out of the Chinese-speaking areas. And the interesting part is what the differences are between them. If you're looking at the Russian-speaking areas, you figure Russia's known for a lot of very complex malware and whatnot, especially on the PC. On the mobile side, they've got really simple Java Trojans and SMS sending Trojans. Like, that's basically the bare, simple, easiest possible thing you could ever do. Okay, hey, let's send an SMS. That's it. That's all they do. That's like Wesber, just like the mugging, just like the red browser in the beginning, the 4-year-old or 5-year-old technique. That's all they're doing. They haven't changed that in about 5 years. They changed it into the strings, the names, whatever. Still the same. The other versions we're seeing, or at least the variety we're seeing in the Chinese-speaking areas, we've got multiple platforms. Oh, actually, let me go back there to the Russian areas. Android is programmed in Java, and it gets converted to a different format, a different bytecode. But basically, on the developer side, it's almost the same thing. So it would have been very simple for a Russian mobile malware developer to just say, okay, let me port my code over to Android. Change a few libraries, and you're pretty much done. Recompile, boom, all the same things. If you're dealing with the Chinese-speaking areas, they're a little more complex. The environment's a little bit more complex. One, you got like millions of users. Two, you've got people doing multiple platforms, Symbian, Android, whatnot. And I'll be covering most of these things in a little bit later with the actual pictures. The key trend, though, is that it's a lot more complex in those areas, and there's a lot more competition. And the competition helps to drive more of the complexity. So instead of just having, okay, I don't know, a simple Trojan, you're having things that go after other either security software or going after other malware writers, other people trying to make money writing basic mobile Trojans or mobile complicated malware, meaning botnets, meaning what else we got out there? Rootkits, pretty much any technique you can use on another platform, they're porting it to the mobile side just so they can keep in business. Let's go on to actually how do they make money. How do you make any kind of money if you're trying to make money with mobile malware? The common way is write it yourself, sell to somebody else, which is kind of a thing that happened with Zitmo, where the first few versions were basically repurposed original malware sold to, or stolen, whatever, I'm not sure exact numbers, from the original author and turned into a way to make money for larger crime syndicates. And distribution basically would be you just put it out there, get your stuff out there, get it on a site, freeware site, download site, pretend to be something else, something like that. I mean, that's kind of that part. But where's the actual money coming from? One thing is premium rate numbers. This is your downloads, your ringtones, pretty much any way to make money doing this. You say, okay, or actually, how do I get some way to take money out of your user's wallet, put it in my wallet? And there are also subscription services, so you sign up once with a premium rate message, and it continually bills you over and over again. Which is nice for the attacker, once again, not for us. Where's the money? Again, other ways to make money. So say you don't want to be so deliberate and so obvious, like taking the money straight out. Okay, like those old 900 numbers and whatnot, and premium rate and telephone numbers, toll fraud they call it in the telecom industry. Basically, you sign somebody else up for one of our services, and it's very obvious because the billing's directed to the device. The other option is basically another thing from the PC side, click fraud. Ad networks, black hat SEO, things like that. I mean, you're driving traffic towards somewhere or trying to pretend to make money out of somebody. What was the deal with the click fraud is basically you have ads and they have fraud detection techniques in place, so if you have like the same guy clicking about 100,000 times, that's going to get tagged. If you get him clicking about 20 times, it's probably going to get tagged. I forget the exact threshold. It's pretty low, I think, for unique individuals or whatnot. So in this case, if you were an attacker and you want to make a bunch of money, you put out something like a botnet and say, okay, I'm going to take over a bunch of different mobile devices, so I've got tons of different IPs, and it's all individual users and all looks legitimately like real traffic. So it's a slow thing, but it's a lot of people. It's been described to me as and I've described it also as basically you're stealing like $1 from about 1 million people. That's a pretty good haul. That's always is. And also, you can also do it the other way, offensively against someone else's ad network and say, okay, take out my competitors and just click on all their ads and wipe them out. Take out their entire budget and take them out. And the next stage is personal identifiable information, which should be your social security number, some other identifying number, maybe your identifying number of your device, something else that they can use to tell directly who you are, which is useful for various reasons. I mean, it could also be account numbers, like a Skype account or something, or a chat account. The key is you can take that kind of information, which is valuable to identity thieves and other people, marketers, legitimately to marketers, and not so much to basically people who would take that and turn it into a currency as identity theft. And they will just resell it in bulk or individually, or use it individually. Once again, the next one is phishing. Phishing. This was similar to the earlier thing I mentioned, the worm, the iPhone jailbreak worm that replaced the website. Not as popular in Europe and North America, well, not at all in North America, but it is quite so in China, which I saw a talk earlier today. If anyone seen that talk yesterday with the phishing going on in China, banks are a big target, and it's really useful to go after something like that. And also, you can download additional malware, maybe spyware, and get a few more details or other accounts. It's very useful. Which is similar to the next slide, really. It's if you have an account like a QQ account, which is a very popular Chinese instant messaging platform, if you're not aware, and you're able to cash out money. You can trade QQ coins on the network and cash it out at various third-party vendors, which is really a black market because it wasn't legal basically cash out the QQ coin, so there will always be some third party, and they will take their cuts, and you will be dealing with organized crime. Very useful. And also, if you're in the business of stealing people's legitimate accounts, there are also money launderers and people who help you clean that money out for you. So you'd sell to them and go through that. Now let's actually look at how they avoid detection and how analysis and make our job a little harder. What happens? Okay, injecting the code into clean apps. We haven't seen file infectors in mobile platforms at all, possibly because we're using Java, but really because no one's trying or no one has to try. So what would you do? You'd inject your code into something like a J2ME app, very easy to compile, add your code into it, recompile, very simple. Symbian, a little harder, more likely Trojans or whatnot, but it's been done, put into like an IM app, someone's invaded in a real IM app and said, okay, repackage it and send it back out. A little harder to do, but they've done it. Android, it's more like things like Droid Dream and a few other major malware families that are really done manually. We haven't seen any evidence it's been automated. Otherwise, you'd be seeing thousands of apps, given that the Android market itself is very open, and the other markets are also, well, the third-party markets are completely open. So it would be really, really easy to target a certain segment of market and just flood all the apps in store with corrupted apps, which we haven't seen. We've seen relatively small numbers, 40, 50, 30, whatever, small enough that a single person could do it overnight or something, could basically produce it, or on their off time they can put together. What's been used to evade detection? Encryption. It ranges from simple to advanced. In a simple range, we've got things like hiding SMS within, let's say, an HTML file. Really, if it's like a standard HTML file on your system, in your data directory or in your browser directory, you're not going to notice. And if it's J2ME, we found this in a J2ME Trojan, you're really not going to notice unless you're having an analyst look at it, and we'd see it. And we'd see, okay, well, where is it? Not too hard. It's actually that little dark section right there. Very simple. They actually put the SMS in the message and then they assume no one's looking at it. Truthfully, if you're a regular user, you're not going to notice it. Then they stepped that game up a little bit by doing another simple technique, simple substitution cipher. Say, okay, we replace digits with like letters or something, or different digits, or whatever it takes. It's really simple, and just putting into the code so you have like an encrypted configuration file. Once again, not for the average user or the victim, but for analysts. Then we went a little step further. We were a little more complex, a little more sensible. They went with like standard ciphers, like DES. I forget exactly what the thing was. Yeah, Android Gainimi. This was one of the first ones to actually encrypt both the URLs that it sends data to, that it posts URLs to the command and control server, and also traffic that it's getting back from the command and control server. So it's like, which is great. It's symmetric cipher, very relatively secure. But once again, not to protect or hide from analysts who would have an access to binary and have access to the actual key. I mean, it's in there already. You can just pick out the key. You have a symmetric cipher. You have the opening. You decrypt. Doesn't stop us. It's really there just to keep you on the network from blocking and seeing that, hey, we're doing something with it, and you can't see. Lovely, right? Oh, okay, yeah, that's right. I forgot. The new version, Droid Dream Lite, and it was a modified version of Droid Dream. It was a little smaller, slightly different. It infected a bunch of malware. And it also used a slightly, I forget if it was DS or AES, relatively standard algorithm, and it used it to hide a couple of root exploits that were used in Droid Dream. Same identical exploits, just encrypted and hidden on before they dropped the disk. Other ways of bypassing protection, also important, like how do you get further infected? We've got things like on Windows Mobile, they disable the silent installation, so you don't even know you're being infected. Real simple, it's just like a registry setting and you change it. Next step is root vulnerabilities. How do we stay on disk? How do we make sure that we're open up device and it can stay on? It's like having a rootkit on, say on a Unix box or Linux box. You're broken in, you say, how do I keep it there? Very useful. And the root exploit gets you onto any mobile device, pretty much, like on an Android device. Anyway, let's go with those. So Droid Dream did it. Droid Dream Lite does it. And the funny thing is that the attackers aren't writing their own exploits. They're not even wasting their time writing their own exploits. They're writing malware that makes them money today. They don't have time to waste time looking for vulnerabilities, spending time to write the exploits themselves. They don't care. And then jailbreaking, kind of. Let's talk about how it reduces security. Has anyone seen that talk at TourCon last year? Eric Monti of Spider Labs, he did a nice proof of concept where he reverse engineered with the jailbreakme.com exploit to remove the warning messages from the exploit and modify it so it's totally silent. So you visit a website, you get a silent drive-by download on a jailbroken, a regular iPhone. And then you have malware installed on your phone. And what was it installed? He installed a keylogger, and he tried it against a very popular credit card processing application. It has a little dongle you attach to your phone, something in that range, and you slide it, and he was able to read the numbers. He could also modify that to send it to himself, to his own control server. And of course, this was on an unpatched phone. He had to unpatch it because Apple had patched it prior, but the same rules apply to pretty much any ODay exploit that gives you root access or gives you jailbreak access, which would give you access to the file system and helps you gain control of whatever you need. The concept really is if you have something that gives you that kind of access, very simple to do and make it malicious. Nothing new, nothing surprising, but you actually went and did it. Let's look at some real malware that's actually out there currently. This first one is a simple SMS sending Trojan. It pretends to be something else. What is it? Oh, okay. Something that helps you send SMS easy, like has templates and patterns or whatever you want. Something interesting. How do you make money doing it? Same deal, sending SMS, for-profit SMS. And this one actually has a couple of choices. You pick 3 different vendors based on your geographical location. Why? Because the short codes that they send the SMS to are also locked by geographic region, and you're not going to make money by sending to somewhere outside. So when we test it outside of, say, Russia, or out of Kazakhstan, or outside of Ukraine, we're not going to be able to test it on the network or test anything in that manner or know that anything is happening, meaning they're very locked geographically. Something a little different, little phishing exercise here. So vContact is a very popular social networking platform in Russia, in Russian-speaking areas, very similar to Facebook. And so it's like, okay, if you can get those codes, if you can get those accounts, you can use them for blackmail. You can use them to gain more people, more contacts. Pretty much exploit it any manner and whatnot. So what does this app do? It pretends to be a mobile client for the. Pretends to be a mobile client for vContact, and say, so you log in, you try to log in, it gives you an error message, and meanwhile in the background it's emailing your credentials to the attacker. Real simple, blackmail users, resell the data, a number of different things you can do to make money. All right, that was straight to me. Let's look at Symbian, which is actually quite complex. And generally, mostly, we're seeing this in China, not so much outside that. These are the most modern Symbian phones with the data protection that wipes out pretty much all the worms that we had 3-4 years ago. Currently, these are much better. You need to have like signed certificates, signed apps, and all things like that. Well, actually, this is an older version. It's Kijia. It was part of a multi-dropper, and it was designed to fool users into thinking, hey, we messed up your phone. They did mess up your phone. They installed a bunch of rubbish on your phone. And it slowed your phone down, and he said, send me some money over QQ coins again, are the money for that instant messaging platform. And it was like, okay, send us some money. I don't think we saw any confirmation that anyone who sent him money ever got their phones fixed or got any kind of fixed tool for it. But it was a pretty good technique. I mean, it tells you to send the money or else, right? Something else on Python, actually, just to show the point that scripting is not just limited to things like Java or whatnot, or simple Trojans aren't just Java. They'll do it with any easy, relaxing thing or simple thing you can pull up. Actually, I believe this is might have been Russian language one. It allows you to send. Yeah, actually it was. Once again, you'll see the type of variation. The previous one tried a little harder, tried to make you think there was a Chinese-based one. The Russian ones, they don't even have to. It's so easy for them, they're not wasting the energy trying to decide, okay, we're going to do something like this. That's a simple thing, pretend to be a chat client and takes your money. Simple. And back to the Chinese again. This is, once again, the more modern Symbian malware, Super Fairy, A and B. A lot of details, a lot of malware. I got about 40 slides here of various things. I have to remember the exact details of each. I have, if you look at the slides on the CD or the DVD that came with your badge, it lists reference to each of these malwares, so you need further details that are there. But how they profit, Superfair, I think, was it added bookmarks to a certain smartphone forum. So you drive traffic towards a given website, and you have people coming in and clicking, and you have multiple infected units or users. So they're actually the real deal with having a bookmark on a phone, like a Symbian phone or a smartphone that's about numbers or whatever for texting, is that if you have a bookmark, you're going to go to that website, regardless of whether anything else is there, because it's a pain in the butt to actually type in www. blah 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 50 long line character URL on with numbers. Difficult. So the bookmark is really a very popular way to get people to come to your site, and it's not so direct. Once again, not so directly traceable like what do you call it? Money things. All right, and we didn't see the second portion there in live. It was already disabled. The forum was disabled. So instead, people were doing what is it called? Trying to get downloaded additional files. So it might have been malware, might have been spyware, could have been adware. Another one, inspirit.a. This was kind of neat. It pretended to be. Once again, this is not like the previous simple SMS Trojan. This is one that's a little more complex. It's trying to pretend to be an actual helpful utility. And this is also kind of interesting how it does its phishing. Earlier I mentioned they were injecting malware injecting SMS messages into your inbox or phishing. If you're phishing normally, you send like a text message to somebody and say, oh, here's a text message from some number that looks like a normal user number, or a number I never recognize, not the number from my bank. These guys say, okay, well, we know the number for the bank. We know how to put the messages into your inbox using the APIs to insert that into your, meaning very complex. We were enough advanced developers to know that, hey, as an attacker, we can put that into your mailbox. You see the text box, text message with an address from your bank. You've seen it maybe before. Every time you log into your website or something, or a message, you can get a service message from your bank. It'll say, okay, here. It looks familiar. It looks like it's from the bank. It's a real number, and it looks very authentic. I mean, it's bypassed basically all the protections you'd normally have as a normal user. Like, how do I know this is real, right? It passes the smell test. Basically, it looks like a duck, walks like a duck. It's probably from my bank. And this one tells you, okay, people have tried logging into your account. Very sneaky technique. We're going to lock you out. Please log in. It's that whole social engineering technique to get you to go and get phished. Pretty useful and a good way to avoid detection. Let's go on to the Android malware, which quite a few. This is the Android Ganemi. This is the first one we mentioned. It was kind of neat. A bunch of infected local applications, and it required a lot of permissions. Very suspicious, and when you actually analyze it, we saw it has that backdoor functionality, so it talks to command and control server, and the attacker can do a bunch of things to you, which is kind of nice. The question is, how to use that to make money? You have a complicated malware. You have a way to talk back and forth to the client, and you have a way to load software, install software, and do a bunch of things. So I can add additional software once I have my team working on something new, and as an attacker, it's saying, okay, I already got something on their devices. How do we get more stuff on there without having to go fool them and infect other applications? And how do we do that? Same deal. And it also went after your contacts. So, okay, we have new targets to go after. We can do things like give them the same messages and whatnot. And pretty much that was gaining me. Another one is Steamy Screen Script. I'm actually not sure how that's pronounced. Usually we try to name these so we can at least pronounce them, but I mean, it was common and pretty much all of us use it. This thing was stealing information that identified your phone specifically. We have various theories on that. Some people think, okay, they're using it to clone it. I don't think there's profit in cloning smartphones as much as it's just stealing the money. If it takes you less time to steal the money, the attacker's probably going to go after that directly. They're not going to waste time trying to clone your phone and say, okay, we're going to use your phone and let me copy it so I can make phone calls. No, they're going to just take the money from you. This one's able to generate SMS messages to your premium rate number, and pretty much the same things Ganemi did without using the root exploits. So the root exploits are very nice. And they really only allow a few different things like, oh, actually, no, I'm thinking about Droid Dream. That's coming up, or at least another version. Here's another one, a variant. This is the calendar application that was infected and modified. Every time you load it up, it goes to January 1st, and you have to move forward to get to whatever date, 2011, I believe. You have to move forward to get to your current date at every time. But every time you move forward, it also, I think about 4 or 5 times, it triggers a payload, and it starts sending out the premium rate messages. And it also deletes messages so you don't know that you're being signed up for like a subscription service to a weather channel or a horoscope or who knows. Very popular concept though. Android T-Cent A was named after it's an app that's named after a variation of the main company behind QQ, the popular instant messaging client. So it pretends actually to be software for that, like a new client or something along those lines for that instant messaging platform. Yeah, okay, there we go. The killing application security application, it actually goes after default security applicants are installed when you install your instant messaging client or if you have it installed already. So it's going after antivirus, it's going after firewalls, it's going after whatever you have on your phone already. It's going after its enemies, basically, which is a lot more complex than we see normally. Not just a simple Java Trojan, but an Android Trojan is going after other people who are trying to clean them off the phones. The game usually is like with rootkits and basically things of that nature. Whoever gets on the device first wins. So if you have security software and you're not protecting yourself, you're probably going to get hit by something like Android T-Cent A. And once again, also does the whole premium rate sending thing. Makes money doing that. So it protects its business and it does its business. Kusin.a, this one tried to be an MMS app. It really doesn't matter what they pretend to be because they're all basically trying to be something they're not and getting up there and saying, okay, install us, and we're good people. That's the social engineering portion. That's the easiest part of it. The hard part is that you've already seen 3 or 4 that are coming out of China and are on Android and are basically looking at each other to like make money off the same basic. Well, okay, we've got about 1 million users or odd here and there, and there's room, but they're still going after the same market. And just saying, okay, we have to worry about all these other characters. And also has a command and control software, and it can get rid of other software, which is nice. So for them, not for anyone else. Another one, nice new one, is Droid Kung Fu. This was discovered by, I forget, but there at the end, I acknowledge them, I'll mention later. This was the one that it was very similar to Droid Dream with the root exploits. It downloads them and gains access and is able to basically stay in areas outside of the standard Android application locations. If anyone's seen the Google, I think the Droid Dream malicious app cleaner from Google, it was an Android market cleaner. It had to use exploits on the same root exploits installed by the malware to clean the malware off the phone, because by default it's not possible for us, security software or Google or anyone else, to delete malware that's not stored in the standard Android application directories, right? And that's where it would be the most important places. It does something similar for making money again, loading URLs in the browser, sending you to generating traffic towards websites and telling them, hey, go over here and anytime. Oh, actually, that's also used for loading ad clicks, basically. Ad click is the URL, you load it up, it's going to be a post or whatever it's going to be, and it's generated as an individual ad click from millions of users. Back one. They're actually quite similar, a lot of these. There we go. PG app, another variation on a family of things that invade, install into legitimate applications and also make money for people. Okay, yeah. So this one signs you up for premium rate services and also adds bookmarks. This one was a little bit more interesting. This is Top Plank A. You might have seen it named Plankton or a few other things. If anyone's seen at SummerCon, I think about 2 years ago, John Oberheim presented a Twilight preview app, which is very nice. It pretended to be an app for the upcoming, I think it was Eclipse at that time. And it's like, okay, so you have a very popular movie coming out and you have an app that pretends to be that. That's a really great way to get people downloaded. So what did his app do? It downloaded binary exploits from his server under his control. It was just a proof of concept, but it was hilarious that people actually downloaded it and were complaining. This app only has 2 pictures. One was the preview app in the Android market, and one was the one his app displays. Like, this is broken. You got about, I think, 100,000 downloads or something for this? Yeah, well, Top Blank and Plankton is very similar. It downloads code, but instead of downloading binary apps, it actually downloads Android code. So it has a class loader to load the class files from an additional APK download from the attacker server. Kind of new, and it also has a few more features like deleting history and deleting bookmarks. Where's the profit in that? You get rid of anything they've users used before, like say Google or Baidu or any search engine or whatnot, and instead you put in bookmarks for your own site. And you say, come to mine instead, because they will. It's really easy. It's there. And you delete the other bookmarks, even worse for them. And also, it has a way of if you've seen the UI talk by TrustSafe, I think it was yesterday, a little early in the day, they were talking about how you can present messages to users like it's a legitimate application. In the same way, Top Blank displays messages and allows them to fish you and say, okay, do this or follow this action or do something very similar and send it out there. Another new app, another Android malware is Base Bridge, which does something similar to the previous two, where it actually goes after security software and AV software, and I think 1 or 2 of them actually go after other malware. I don't have names for those at the moment. How would they profit from something like this? Same deal, sending SMS message to a premium rate message and signing it up. In various places, it's easy to get a premium rate account where you provide a service for a certain amount of money. You might have seen ads on television and say, okay, sign up for this ringtone thing or whatever it is, and then on the small print it'll be like, this is a repeating service. It repeats like for, I don't know, every month you get billed like $10 or whatever. Small amount of money here, and then something works very similar everywhere else. Then we have another one, J.SMS Hider. Pretty much does the same thing, sending premium messages and installing additional malware. Not too complicated. And then we have something like Gold Dream. If anyone's seen the article that was posted today, saying that Gold Dream is a malware that records your conversations and records audio from an Android phones. Not this malware. That's another one called Android Nickus, but I don't have a slide for that because it's not really a for-profit malware. It's really more of spyware or whatnot, or malicious spyware. Not the same thing. Not for-profit. Gold Dream was doing the same thing, going after banking by intercepting mobile TANs. So it's just like the Zeus in the mobile, the one where you might have seen the Zeus Crime Rate toolkit that does phishing on the PC side. They have a mobile portion that it sends the SMS messages. This is very similar, and it'll intercept your SMS messages that have your authorization code. This is like those RSA tokens that change every 60 seconds. I heard from somebody yesterday that it was maybe 30 seconds in the SMS. A text message authorization code, which is about 6 digits, a small amount of numbers, lasts about 30 seconds. So long enough for a network to get it to you, like almost instantly. And depending on how small that window is, it also affects how the attacker goes after your bank account. So if it's a short amount of time, they need to be on it at the same time you're on it, on the account. So they'll log in instantly. I talked to another guy who said, okay, he's monitoring financial transactions. We don't get to see those as much. But on the financial transaction side, you can see that how the malware does it versus how an average user would do it. If you log in as a bank account user and then you move money, you got to go through the menus, got to click, takes you a few minutes. Average time maybe 5 minutes if you know exactly what you're doing. With the malware, they were seeing traffic patterns that look like this is PC malware. About a login followed by about 2 seconds later a transfer. So a big difference and very easy to detect. There's a paper coming out on this in a couple of weeks from the other researcher. Right, same deal, sends premium rate messages, and adding new software, which is always bad because everything we're seeing here could have been variants installed by any of the previous ones coming before it. And it actually shows the pattern that people are actually trying to come after your money now. They're doing it on mobile devices, and they're looking for ways to get to you easily. And once again, all they need to do if they have something that is complex is to be the first one on the phone before any protection, before anybody else helping out. So we tend to recommend look at the reviews if you can, see if there's something's very popular. Try to avoid as much the newer untested applications that have maybe 5 or 10 downloads. If you can, some kind of reputational service, maybe somebody your friend knows something. Rather that before we have something before somebody provides you that, or try any of the other various people providing security software on the markets now. Another application, Hippo SMS. This was another one inserted code into an application. A bit repetitive, some of these things that, I mean, they're on platforms. The real key, the interesting part is how they make money and how they go after each other who are trying to make money. Other attackers are also trying to make money. That's a neat portion. But same deal, deletes messages so you have no idea you're signed up to a subscription service. Let's see, what have I got left? Okay, this is the actual, something more interesting. This is a proof of concept, not a malware. This is SoundComber. It was called initially SoundMiner. You might have seen the videos online. This is basically a university project testing how to create an app that uses very few permissions and is able to do something like taking your interactive voice response, your basically those menus you press 1, press 2, whatever, like the ones you call your credit card company. Okay, at some point at one of those calls, you're going to be typing in your credit card number, or you're going to be saying your credit card number, and that's a pretty good target. SoundComber goes after that. It's made of 2 pieces. One is I think the deliverer. It's got the deliverer, and SoundComber the app. So the first part gathers audio from your microphone to overhear you either saying your credit card number or typing it in. It'll actually listen to DTMF when you type in your credit card number into the phone. You figure, wow, it's right there. They're sitting there, and it's not somebody next to me stealing my information. It's the phone itself going after me. Now, it doesn't need to do anything more than that to the SoundComber app, but it does pass it to the second app, the deliverer, which does something interesting. It processes the files because they know process sound files and sends them back out to over, I forget what it was exactly, a very small amount of data. Was it sound? I forget. How do they actually make money? They've got a fingerprint database for a number of credit card companies, the interactive voice response system, so they know, okay, this is the point where the user has hit the number and gone to like press 1 and 2 and they enter your credit card number stage. Is okay, we'll hit that. We'll go after that location and say, okay, we'll just gather, like, say, the 10 seconds it takes him or 30 seconds it takes him to say the number. And then we'll take that, put it on disk, and then scan that or process that in that specific sound clip for the digits. Now, their detection or their processing of sound was pretty good, and it was able to get about out of a 16-digit number, maybe they'll have a little trouble with like 15 digits, and like maybe the last number might be cut off or something, depending on how long they recorded. But since you've got 16 digits and then there are only like 9 digits that could be, they can just route through them until they actually get your number. Very convenient, very neat, very few permissions. Not as many as I believe as they show in their video, something about a torch application or a sound application. Nothing like that. Very limited, and they can still do damage. We have not seen this live in a real malware outside yet, but it looks very interesting. It looks like people could do this in the market or in the wild. And we might eventually see this soon. All right, thank you. All right, and that's pretty much the rest of that application. We have references in the presentation for all of the malware here with actual technical details and a bit more data on the application, maybe a few images. And we were referencing the Soundcomber presentation by the team at. They presented earlier. I forget exactly what university they're from, because it was actually a bunch of people from a number of universities that got together and put this together. Very nice project. There's a video there, and a few acknowledgments that people provide information on the crimeware and how people actually make money doing this. People actually test this against this. Theodore Bohm of I think it's 000. I'm not exactly sure how you pronounce the name of his thing. He'd done a talk on. From Russia with love.exe, where was an example of how Russian criminals were making money out of PC malware and getting money from you. And I also talked to Billy Lee and then Tom Panpan of Anti-Y Labs. They provided a lot more information on China. And once again, a team with Soundcomber, and also Dr. Zhang of North Carolina State University, who found a bunch of the samples in the latter part of the presentation. Another colleague, Zhang Bu, helped me out with the Chinese market a little bit more, and also Joey Zhu. If you've seen his talk on phishing yesterday, he was quite helpful clearing up a few details. Were there any questions regarding any of these? Yeah.
So, with these premium rate applications, how do the hackers actually get the money out, or is it some kind of redirection? I mean, are they running that premium rate service?
The question is, how do the hackers get to the premium rate, get paid when they're doing the premium rate SMS attacks? Is that right?
So if they sign people up, are they running that service, or is somebody else running that service?
So you're asking if do they run the premium rate service, or are they getting it to a third party? A little bit of both, actually. The premium rate service, I understand in Russia, it's easy to get an anonymous premium rate number and have people dial that number and collect the money and then disappear afterwards. So it's a little easier in certain markets to do that. I understand we have to move to the QA room. It's track 3 QA. I think it's across the hall. Thank you.